All right, this is part 2 of inverse functions. In part 1, we talked about when a function has an inverse and how to verify. Today, we're going to talk about how to find a function's inverse. Now, the key to doing that is to switch x and y. Remember that in a function, x is the input and y is the output. So when you switch them, it switches inputs and outputs, and it basically makes that equation do everything it did but backwards. So let's start off with a nice simple one. We have y equals 6x. If I switch x and y, I get x equals 6y. And that's what I mean when I say switch x and y. You take the equation, anywhere there's a y, you change it into an x, and anywhere there's an x, you change it into a y. Now if I solve for the new y, basically divide both sides by 6, those 6's over here cancel, and I get y equals x over 6. Those are inverse functions, y equals 6x and y equals x over 6. Now that's a very simple example. That's basically just multiplying and dividing. The first equation says take x and multiply it by 6. And the second equation says take x and divide it by 6. So yeah, they're definitely inverses, multiplying by 6 and dividing by 6. That's an overly simplified example just to show you how to do it. Now what we're going to focus on is more complicated equations, not just y equals 6x, but more complicated functions. So here are the steps to finding the inverse. Number 1, what we talked about in part 1. You want to use the horizontal line test to decide if f is 1 to 1. If it's not 1 to 1, you're done. You just say this function doesn't have an inverse and you move on to the next question. If it is 1 to 1, here are the steps. So number 1, we're going to rewrite the equation out of function notation. If it's f of x or g of x or h of x or whatever, just rewrite it using y instead. And the reason we do that is because we're going to do what we just talked about. We're going to switch x and y. You don't want to switch x with f of x because it looks funny having an f of x in the middle of an equation. You solve for the new y, which is what we did on the last one. It's going to be a few more steps than just dividing by 6. But basically, once you've done that, you have the inverse, and the last thing you want to do is rename it. So we're going to switch back to function notation. The new y, which is the inverse, we will call f inverse of x, or g inverse of x, or whatever the original was. So let's do an example here. This is actually the example that we did at the very end of part 1. I gave you this function f of x equals square root of 2x minus 3, and all I did in part 1 is I asked you whether or not it's 1 to 1. And we decided it is, which means it does have an inverse. So let's continue on from there and actually find the inverse. So we said, what I want to do to find an inverse is switch x and y. Now, what I'm going to do in order to be able to do that, just take this f of x and rewrite it as y instead. F of x and y are essentially the same thing. Now we do that step where we switch x and y. So instead of y equals, I have x equals. And I'm going to recopy the same equation, only instead of each x, there's only one in this one, but if there's more, instead of each x, I'm going to change it to a y. So instead of the square root of 2x minus 3, I have the square root of 2y minus 3. So at that step right there, just by doing that step, you have actually created an inverse. By switching x and y, the equation now works backwards. But the answer to the question needs to be y equals. So all I need to do is take that new equation and solve it for y. So my first step for solving this equation would be to square both sides. Because the square and the square root will cancel and leave just an ordinary 2y minus 3. My next step would probably be add 3 to both sides to cancel that out. And we have x squared plus 3 equals 2y. The last step is to divide by 2. And basically, once you've done that, once you've solved for y, this is the answer to the question. But what I want to do is just rename it. So if I look back at the original problem up here, the original function, before I change it to y, was called f of x. that makes what I circled at the bottom its inverse, f inverse of x. So for my final answer, I'm going to say f inverse of x equals, and then just copy the exact function, x squared plus 3 over 2. And that right there is your final answer. Okay, so the last thing I want to talk to you guys about today is something called restricting domain. And to restrict the domain, to restrict something means to only use part of it. So you're saying, instead of using all real numbers, I'm only going to use certain values. It basically looks just like and works just like one part of a piecewise function. So basically what you're going to see is you're going to see your equation, f of x equals something, like 3x plus 5, and then it's going to say comma, and there will be some little inequality after it. X is less than 4 is the example I used, or x is greater than 10, or x is greater than or equal to 0, something like that. Now what that means is I'm using the function 3x plus 5, but only for numbers that are less than 4. And when you do that, what you can do is you can take a function that is not one-to-one, and you can make it one-to-one so that it has an inverse and you can find it. So for example, we said earlier, we said in part 1, a parabola is not one-to-one. F of x equals x squared fails the horizontal line test, it's not one-to-one. But we very commonly think to ourselves, yeah, squaring and square rooting are inverses. How can that be if x squared doesn't even have an inverse? Well, what we can do is this. So I'm going to go up to the side here and draw you a quick sketch of what's happening. So here's my graph of x squared, and it's not one-to-one, because if I draw that horizontal line through it, it crosses it twice. Well, what I did here is I restricted the domain. I said I'm only using x is greater than or equal to 0. Well, that means I'm only using numbers to the right of that dotted purple line right there. What it means is I'm getting rid of that whole part of the graph. Now all of a sudden it is one-to-one, and it does have an inverse. So basically what's happening here is we're taking something that is not one-to-one, we're only looking at part of it, so it is one-to-one, and then we're giving it an inverse. And that makes sense if you think about it in terms of what we know too, because what we're really saying here is x squared and square root of x are inverses as long as you're using positive numbers. They're not inverses if you use negative numbers, because you can't even take a square root of a negative. So it's out of the domain. So this is called restricting the domain. If in the homework you guys see a question that looks like this here, where it says f of x equals, and it gives you an equation, and then it says comma, and there's an inequality after it, the inequality is restricting the domain. It's there to make something that's not one-to-one, one-to-one, and it's going to make you able to find that inverse. So I asked you guys to graph the following function. We actually just did it. I said, does it have an inverse? If so, find it. So basically, our graph from the last slide ended up just being the right half of a parabola, which, yes, it is. It is one-to-one, and it does have an inverse. So when you find the inverse, we're going to do the same steps we just did. I'm going to take that f of x, and I'm going to change it to a y. So I have y equals x squared. I switch x and y. This would be x equals y squared. I take the square root of both sides. You get, now, normally when you take the square root of both sides, you get a plus or minus. The plus or minus, the minus, like, that depends on which half you restrict it. Because basically, if I had said, if you look up here at the top, if I change that to x is less than or equal to 0, you get the other half of the parabola, which is still one-to-one. So basically what I'm getting for my answer here is plus or minus square root of x. The positive square root of x is the inverse of the blue graph, and the negative square root of x is the inverse of the red graph. So since we are using the blue graph, my answer would just be y equals square root of x. All right, I hope that makes sense to you guys, and I hope that's enough for you guys to finish our next assignment. Work on assignment, I think it's number 5, and I'll answer questions in class tomorrow.